started. All right, today we're going to do 5.3 medians and altitudes. All right, before we do that, let's kind of go back and look at what we did on 5.1 and 5.2. 5.1 we talked about the perpendicular and angle bisectors. Okay, so what those two things are. Right, a perpendicular bisector is if you have 2 points, it's a line where you can draw that as perpendicular to the line segment and it bisects it, obviously. That's a perpendicular bisector, right? An angle bisector is when you have an angle as such and you draw a line in the middle such that this angle and this angle are the same, right? That's the angle bisector. Okay, so that was what we did in 5.1 quickly, right? 5.2, we talked about, well, what happens if we put these in a triangle, right? If we have a triangle like this, right, and I put the perpendicular bisectors here, if I take the perpendicular bisector and I connected the dots of this perpendicular bisector, this guy, and I took this guy, and I connected them together, I get something that's in here, right? And what is this called? Does anybody remember what this is called? It's called the circumcenter, right? The circumcenter, because we are now going to be able to say that this and this length are all the same, and we can draw a circle on the outside, so it's called the circumcenter. Okay, so that was a circumcenter. And then we had, well, if we did the angle bisectors of a triangle, if we took the triangle and we took the angle bisectors and we connected them together, you would get something here, and we could say that this distance, and this distance would be the same. You can actually inscribe a circle. Therefore, this guy was called the incenter, okay? So we talked about the circumcenter and the incenter in 5.1 and 5.2, right? In 5.2, we talked about that, okay? All right. So here we go. So we're going to add to those today. We're going to go in 5.3 and 5.3. We're going to talk about, first we're going to talk about the centroid. Okay. Centroid is in any polygon, all right, if you, what you're trying to find is a point where you can balance that polygon, whether it's a triangle or whatever it may be, that shape on a single point, where the weight would be just, the mass would be distributed evenly, so it would just stay there on one point and balance on one point. And that's called the centroid. Okay, the way we find the centroid is we take, in the triangle, we're going to take the midpoint here, so this and this are the same, the midpoint here, so we're going to connect that with the angle over here. We're going to take the midpoint here where it bisects this, and we're going to go like that, and we're going to take the midpoint here where this guy and this guy are the same, and you have a point here where that connects, okay? And this is what we call the centroid, okay? An interesting thing happens here is that when you find the centroid is located on each of these lines. It's at a point where this is 1 and this would be 2. In other words, if this was 3, the length from here to here was 3, this length here would be 6. If this length from here to here was 4, this length to here would be 8. In other words, it's always going to be 1 to 2, 1 to 2, right? Same thing over here. If this length here was 5, this length here would be 10, okay? So it's going to be at the 2/3 or 1, depending on where you're looking at, from here to here, then it cuts it such that this is 1 and this is 2. Okay. In other words, 3 to 6, 4, 8, 5, 10, right? It's always going to be that 1 to 2 ratio there. Okay. All right. So if you go to bottom of page 326, Theorem 5.3-1, if you're going to go ahead and read that, and that basically discusses what we just talked about. Okay. All right, so that's the centroid. That's the centroid. Let's go ahead and look at example number 1. Example number 1, we have using the centroid to find the segment lengths. In ABC, we have AF is 9, GE is 2.4. Find each length. So let's go ahead and start drawing this. Okay, I have B, A, C, E, F, G, like that, and what? D, E, F, I'm sorry, D, E, F, and G is the centroid right there. So I know that AF is 9, AF is 9. So this is 9, okay? And then they want to know what AG is, this guy here, right? So we know that the centroid is going to be the 2 to 1 set point here. So in order to do that, this has to be 6 and this has to be 3 because it adds to 9, right? Adds to 9 and it is 2 to 1, right? 2 to 1. So therefore, AG is going to be 6, okay? And then we have CE. They want to know what CE is. They're giving us GE. They're telling us that on B, we know that GE is 2.4. So if this guy is 1, this guy's going to be 2, right? So this guy here, or in other words, GC is going to be equal to 2 times 2.4, which is 4.8. And what are we trying to find? We're trying to find the entire C to E. So it's going to be 4.8 plus 2.4, 7.2. Okay? All right. All right, now let's go ahead and look at example number 2. Example number 2, we have the diagram shows the plan for a triangular piece of a mobile, I guess. Where should the sculptor attach support such that the triangle is balanced? In other words, find me the centroid. We're trying to find the centroid, okay? And I have this point here is 0, 8. Then I have here is 3, 0. And the other point as 6 and 4, 6 and 4. Six and 4. We want to find the centroid here, so let's go ahead and find the centroid. So to find the centroid, we need to find the midpoints of these things, right? So let's find the midpoint. So I do the midpoint of here. So let's go ahead and try to find the midpoint here, right? The midpoint here is going to be the midpoint with these 2 points, right? So you're going to have to add x1 plus x2 divided by 2 for the x. For the y, you're going to have 8 plus 4 divided by 2. So this is the same as 6 divided by 2, which is 3. This is going to be 12 divided by 2, which is 6. Okay, so an interesting thing happens here. The thing that happens here is that we have the same 3 here, right? So that I know from here to here, the distance is going to be what? Nothing more than from 0 to 6. So this length here is going to be 6. This total length is going to be 6. But the centroid is going to be a point where it is going to be 2 to 1. So in order to cut 6 2 to 1, this is going to have to be 2. This guy's going to have to be 4. Therefore, this guy here is going to be 3 and 4. From here to here is going to be 4. Here to here is going to be 2. So this guy here is going to be 3 to 4. And that is going to be my centroid right there. Okay, so I got lucky here because I had the 3 and the 3 together. Okay, because they were the same and it was easy for me to find the distance there. Okay. 3 and 4, let's flip the page. Let's go to, now we're going to talk about an altitude, right? We talked about the median. So now let's talk about the altitude. Altitude is similar to the median, except for the altitude, okay? Now we're going to go ahead and we're not going to cut this in half and connect it here. We're going to take a line that is perpendicular to this. That's an altitude, right? That's what we call an altitude. If I do that, so if I find a line under here that is perpendicular to this line here, the last one is I have one that's perpendicular here, and then it's going to go to here. So I take this as perpendicular. Okay, these 3 lines are going to meet at one point. This guy is called the orthocenter. Okay. The orthocenter is kind of similar with the circumcenter. If you remember, the circumcenter on an obtuse triangle was actually located outside of the triangle. Orthocenter is the same way, okay? If you have an obtuse angle, or obtuse triangle, right? Then the orthocenter will be located outside of the triangle, just as the circumcenter was. Okay, so this is called the orthocenter. So let's see, so the altitude, so we're connecting the altitudes, right? The altitude is nothing more than taking this point here, and you draw a line that is perpendicular to the opposite segment. The opposite segment is over here. I'm drawing a line that is perpendicular. Over here, the opposite segment would be this segment here, and I'm drawing a line that is perpendicular to that. Okay? All right. If you connect those, we have what is called the orthocenter. Okay? So, and that is written down on page 328 in the middle section. So go ahead and read that. Okay, the book says that, so it's the orthocenter, so it kind of shows you what the orthocenter is. Now, the one on page 328 exactly is a triangle that is an obtuse triangle. As you can see, the orthocenter is located outside of the triangle. Okay, all right. Okay, let's go to example number 3. Example number 3, we have find the orthocenter of JKL with vertices. We have K, which is -2 and 6, -2 and 6. So this is K, -2 and 6. And then we have J, which is -4 and 2, J, which is -4 and 2. Then we have L, which is 2 and 2. So here, this is L, 2 and 2. Okay, so we have a triangle here. Okay, so trying to find the orthocenter here. To find the orthocenter, all right, let's go ahead and do the one that's easiest. And the one that's easiest is going to be this guy here, right? Because I know this is the y values of both of these are 2. So I know that this guy is parallel to this y-axis, right? So it'd be easy for me to draw a line down here, right? Okay, so I can do that. And then let's go ahead and see if we can find this guy. Okay. So this guy here, I know this line, right? So what is the equation for this line? The equation for this line is that x, so this equation is going to be x is equal to -2, right? Because it's a vertical line, which means it's going to be x is something, and that something is it goes through this point, which has a -2 here. So this is going to be x equal to -2. Okay. Now I'm going to find the line that is going to go perpendicular from here to here. So I'm going to try to find the equation for this line here. Okay. Well, since I know this is perpendicular to this line, if I found the slope for this one, the slope for this one is going to be the opposite reciprocal, right? Because it's perpendicular. When you have perpendicular slopes, they are opposite reciprocals, and we know that. So let's go ahead and find the slope of this line here. The slope of this line is the slope of these 2 points here, right? So the slope of those 2 points are going to be delta y over delta x. Delta y here is going to be, let's go 2 minus 6. X is going to be 2 minus 2. Okay, if I do that, I'm going to get -4 on top, negative, so it's going to be 2 plus 2, which is going to be 4. So my slope for this line is -1, which means that the slope for this guy is the opposite reciprocal of this. So it's going to be -1 over -1. Minuses cancel out. It's going to be 1. So the slope of this is 1. And it goes through this point. So what equation should I be using here? Anybody? Carter, what equation should I be using? Carter, are you there?
I'm sorry, I don't know.
Okay. What 3 kinds of equations do we know for lines?
Is it point slope form?
Yes, you want to use the point slope form, right? Good job. So I know that it goes through this point right here. I know that the slope is 1. The point slope equation, if you remember, is y minus y1 is equal to mx minus x1. And it goes through this point here, and I know that the m is going to be equal to 1. So I'm going to have y minus y1, which is 2, m, which is 1, x minus 4, right? Okay. Move this up here. This was x equals -2. So this is the equation, which is going to be y minus 2 is equal to x plus 4. Y is equal to x plus 6. Okay, so that's the equation of this line right here. And I know it's going to meet with this line right here. So I have to find those 2 points. I have to find where these 2 lines intersect. Well, I already know what x is. All I need is to put x in here, and y is going to be equal to what? -2 plus 6. That's plus 4. So the point is where they intersect, and that's what I'm trying to find, right? I'm trying to find that guy right there. I'm trying to find the orthocenter. So it's going to be -2 and 4. And that right here should be my answer. Okay, so this is a little drawn out, obviously. This is not the easiest question in the world, right? Okay, So you're gonna have -2, 4, but the way you found that is to find this line, which was x equals to -2, and then to finding this line. So finding this line was kind of tough because you had to find the slope of this guy, do the opposite reciprocal of that, and then put it in the point slope equation. Many steps involved here, okay? All right. All right, we're good. We're good with that. Any questions on this one? All right, let me go ahead and assign some homework here. This was 5.3. Your homework is 1 through 15, 17 through 31.